Alright, so I will guide you through this production possibility frontier curve slowly. Okay, so please spare me a few minutes to talk about this. Alright, so you can actually see that there is a two good production economy. Let's assume that this economy only produce robots and weeds. Alright, so on your y-axis, it measures the amount of weeds you produce, and on your x-axis, it measures the amount of robots you produce. Okay, and you actually have a bowl-shaped curve down here. Okay, and each of these points, okay, they actually measure to you the production combination of each economy. Alright, so you can actually see that the first points denotes 0, 16, 0 robots, 16 wheat. Okay, the second one will denote 1 robot, 15 wheat. Third one will be 2 robots, 13 wheat. Fourth one will be 3 robots, 10 wheats. Okay, 4, 6, and 5, 0. So any production along the frontier, it is known as an efficient outcome. Okay, meaning to say all your labor, all your capital, all your inputs, okay, are devoted into production. Okay, and all your resources are effectively or efficiently used to produce all these goods. Okay, and naturally we can be producing within the frontier itself. Okay, when we are producing within the frontier, alright, this is known as an inefficient outcome. Okay, or your resources are not deployed fully to produce. Okay, that is why you are producing within the frontier. These are all inefficient production methods. Alright, and if you want to produce out of the frontier, it is not possible because you do not have the resources to do so. Remember, the efficient outcome tells you that all your resources are fully deployed. Okay, but if you want to produce out of the frontier, you will have to acquire more production inputs to produce outside. All right. So let me explain the bowl-shaped curve, okay, using a story to illustrate the concept of increasing opportunity cost. All right, and imperfect mobility of labor. All right, so let's assume that the first point is 0, 16. So it tells you that the economy can be producing 0 robots and 16 units of wheat. All right, and if it wants to produce 1 unit of robot, okay, you realize that what? Okay, you will give up 1 unit of wheat to produce 1 unit of robot. Okay, meaning to say you have to pull labor from the wheat production to produce robot. Okay, so for the first labor that you pull over, okay, from the wheat production to the robot, okay, this labor may be well equipped with both production. All right, in the sense that he is a super soldier, super labor. All right, okay, just by using one labor like this, you're able to increase 1 unit of robot production by giving up 1 wheat. Okay, but you realize that once you want to produce another unit of robot, okay, you have to give up 2 units of wheat. All right, so in order to produce 1 more unit of robot, you need to pull more labor into robot production from wheat. Okay, and the labor that you are starting to pulling from the wheat production to the robot, the quality of the labor may not be suitable for robot production. Okay, and this is why you have to give up more wheat in order to produce 1 unit of robot. All right, you have to take more workers from the wheat production in order to produce 1 additional unit of robot. All right. And similarly, if you want to produce 1 more unit of robot, now you have to give up 3 units of wheat, meaning to say you have to pull more workers from wheat production to produce an additional unit of robot because of labor immobility. All right, your labor does not have the perfect skill set to produce the two goods. Alright, so you realize that there is increasing opportunity cost in robot production. For every 1 robot to be produced, okay, you have to give up more and more wheat. okay, until you reach the other end. Okay, and if you work backwards, the idea is the same. All right, and because of increasing opportunity cost, your PPF curve is a bowl-shaped curve. Okay, or sometimes you may hear concave. All right, bowl-shaped or concave. All right.